So this first problem is asking you to identify the exponent and the coefficient for each of the following power functions. So this means that we're looking for a solution, or to rewrite the function as a constant times x, if that's the independent variable, to the power of p, where that's integer or a fraction or whatever. So for the first one, you would start by realizing that because you have an x cubed in the denominator, that could become a negative exponent. So you could rewrite this as 7/2 times x to the negative 3. And if you do that, then you're done. Your coefficient would be 7/2, and your exponent would be negative 3. Very similar for the rest of these. It's just applying exponent rules to get it to match this form. So for part B, you would use the idea that you would use here that say the nth root of something to the mth power is x to the m over n. So if you were writing this, you would say this is x to the 1/3, because I have a power of 1 in the x under the radical, and n is 3, so it's x to the 1/3. So your coefficient would be 6, and your exponent would be, 1/3. Okay. For part, let's do part D. So you have this fraction of 2/3 be multiplied with the rest of it, so that can just come out. Just multiply this, x to the 4th over square root x. And using this rule up above for the radical and fractional exponent, we can write this as 2/3 times x to the 4th power divided by x to the 1/2, because that's the representation for the square root. And so now we know that when you divide a common base, you subtract the exponent. So this is 2/3 x 4 minus 1/2 in the exponent, so that's 2/3 times x to the 7/2, because 4 minus 1/2 is 3.5, and as a fraction, that's 7/2. So this would be your power function. All right, let's do one more. Part E here. The first step is to distribute this negative second power to everything inside. So using the property that if you raise a product to a power, it's the same as putting the power on each term in the product. And so this is 5 to the negative second power times x squared, right, that whole term, the negative second power. So 5 to the negative 2, x to the negative 4th, because when you raise to a power, right, that's a generalization of this. You just put the negative 2 to everything inside, and so these multiply and you get negative 4, which means, and you can also rewrite this as 1/25 times x to the negative 4th. So your coefficient would be either you could say 5 to the negative 2, or you could say 1/25, and in either case your exponent is negative 4. Okay, so that's about converting it into this form. The other thing we can do is we can draw graphs of the functions given various exponents. So for example, here you have a negative coefficient and you have an exponent of 5/4. So 5/4 is obviously greater than 1 and is a fraction. So we know that the graph of this would look something like this. Okay. For part B, you have an exponent of -3. So you have an integer exponent, and it's an odd number. So we know that the graph will follow like a 1 over x behavior. But because of the negative coefficient, this is mirrored about, like, this is the positive case. So your graph would be the reflection of that. So it would look like this, like that. And for the last one, let's do part C for now. But this one, you have exponent that's a negative integer, and it's an even number. So if you had a positive coefficient, which we do, it would look like this. The branches would both be in the upper plane. And if it's a positive coefficient, it just stays there. So that would be your answer for that.